welcome out there. Mathline time, you've got it, all right? Specialized segments, you got it also, and it is summer school. I'm Ernie Roberts, I'm your host for Mathline. Now, whether you're watching us via streaming, whether you're watching us on YouTube, whether you're watching us whatever time of day it is, we're glad you've tuned in, all right? We're glad to have you with us today. Do not try to call us. We're not around. However, you can still send us Facebook notes, and also you can send us things on our email stuff and all. So we're glad to communicate with you, but you just got to work a little harder, I guess. You can't just call in and say, hey, Ernie, how do I work this problem, all right? We're going to give you some stuff to work with all summer long here with summer school. It's laid back time. It's exciting. It's fun. And a lot of times we get back to the basics. So let's see where we're going today. What's our storyline? We're going to be a bit rational today. I agree. Let's be a bit rational. Summer school, laid back, like I said. Sit back. You got your pencils, got your papers. I don't know if you're going to need a calculator. You might want to have one close by. And let's do some math, all right? Let's talk about it. Subsets, real number system that apply to the lucky number 7. Now, what in the world do we mean by the lucky number 7? Well, just what it says. It's a digit. It's 7 apples, 7 oranges, whatever. We always tend to think 7 is a lucky number for some crazy reason. Well, there are a lot of rationale behind that. We'll get to that another day. But what we want to talk with here are these subsets. Subsets are sets within a bigger set. So in the real number system, you're going like, whoa, Ernie, all this stuff. This is like your pre-algebra moments here and your algebra 1 moments that some of you went like, ooh, vocabulary, words, terminology, and so forth. So what we're going to ask ourselves here, first of all, a real number is either rational or irrational. Basically, they can come into 2 categories. Now, anything beyond that, anything that we cannot call irrational or rational, is just not part of the real number system. It's its own little realm, okay? Some of you go like, there's stuff that's not real. Some of you probably think most of the math is not real, but really, we do have some good numbers that work with us, but the irrationals we're going to avoid today. Remember we said we're going to be rational, right? So that's the first thing. So let's talk about real. Yes, it is. 7 is a real number. Is it, I use that word rational? Rational. Can it be written as the quotient of 2 integers? In other words, can we write it like a fraction? Well, we can put 7, we drop a 1 under it, so, and that equals 7. So is it rational? Yes, it is. It's rational. Is it an integer? You're thinking, oh my goodness, Ernie, you're really getting picky, aren't you? Is it an integer? Well, is it a positive, negative, whole number, or 0? Well, whole number includes 0, doesn't it? So what do we think? Yes, it is. So good news there. It's an integer. Now, some of you think, well, integers are all negative. No, they aren't. No, they aren't. Integers, like I said, are positive and negative. Natural numbers, counting numbers, whatever you want to call them there, whole numbers, and the 0, all right? Now, let's go with whole numbers. And remember, whole numbers, they include 0. Now, those are your counting numbers and 0. Used to be we didn't have a number that represented 0. That represented nothing. So we've had all this counting. We go 1, 2, 3, 4, 5, 6. But, oh, what happens when we don't have anything? Well, we needed a number. That would be 0. But that makes the whole numbers. And yes, 7 is part of the counting numbers and 0. All right? Doesn't equal 0, but you get my idea. All right? It's part of that set. What about, I use the word natural numbers, which are also sometimes called our counting numbers, which we learned when we were probably 3, 4, 5 years old when we first started learning how to count. Some of you even started learning how to count when you were 2 and such. But you get the idea. Those are the natural numbers. So these are the sets it's all a part of. Which of the sets have I mentioned on the show so far is it not a part of? It is not irrational. Okay? And an irrational simply means you can't write it as a fraction. All right? Can't write it as in terms of an integer. And when we talk about a fraction, as an integer over an integer. That gives you a specific value. Okay? So there you have it, a little start. What do we mean with rational? So we're going to deal with, basically today, we're going to stay rational. All right? We're not going to see any irrational numbers. Some of you are going, phew, I'm not ready to be irrational on a Monday or whatever daytime you are looking at this, right? So let's check it and see where we're going to go. Let's put some rational numbers into action here. We're going to order these values from least to greatest. Now, some of you are going like, well, you mentioned they're all rational. Yes, I did. If you have what we call a terminating decimal situation here, and these are all pretty much determined that they're terminating. Boy, a lot of terms in there, aren't there? As 3 1/10. Yep, we can write that. We can write that as a ratio between two integers. Same thing with 2 9/10. Whoa, 2 95/100. Yeah, we can do that. 33/10. It's already written as a rational number, as is 10/3. And this little guy here, yes, so they're all rational. So that's easy, isn't it? Some of you say, oh, no. Well, we want to rank them from least to greatest. So what would be nice is if we had an idea where these ranked as decimals, because when we look at the decimals, it's so much easier to determine, oh, yeah, we can pick those up right off the bat. And at this point, let's take a look. Let's take a look. Let's look at a nice, easy way. This is geared to our younger viewers and to our older viewers who sometimes have trouble determining which of these is bigger, all right? And if you put a 0 on the end, which you can do, think about your money, $2.90 versus $2.95, it's easy. A lot of times we look at, if we look at the 2.9 or 2 9/10 and we think, oh, well, there's one less decimal place, that's why it's smaller. No, it isn't. You put a 0, you compare them head on. That way, you'll get the accurate answer. Because if I had put, let's say this was 8.5 here, and some of you said, well, that's got less decimal business after only one place versus two places. Some people think that way, but that's not the way it works. Okay, put a 0. Let's do that right on the bat here. Let's go ahead and figure out what 10/3 is. That's 3 1/3. So that would be 3, and you've got that repeating decimal 3 moment. Note I'm putting a bar over that, and that just gives you a hint to a question I may ask later on the show. We'll see what happens. Here, by the way, we may add as many 3s as we need. Here, let's go ahead and make this look like a decimal. Let's put a 3 and a decimal 1 there. Okay, 3.1 is in good shape, but you know what? We might need a little help out of that. Let's put another 0 there. I already mentioned that we could change this 9/10 to 90/100. Okay. This one, why not? Let's keep it alone. Some of you say, Ernie, why did you leave that one alone? Because notice 2 decimal places is all I need to be able to order these. So I don't need to go any further, add any more zeros and such. Got it? And what is this going to give us? 33/10. Quick thought. Can we do some mental math? It means we're going to divide by 10. We're going to move that decimal. It's in 33. We're going to move it one place to the left. And that's going to give us 3 3/10, or why not add a 0 to it? We'll make that become. So now it's very easy to compare these things. By the way, you can put another 3. Everybody wants to put another 3 down there. So we got the same amount. I agree. And then that's all ready to go. Now we can put them together. But we want to go back to our original, quote, look. All right, when we do put them together from least to smallest. Well, and by the way, easy thing, slash them. Slash them as you get through them, all right? Some of you are going like, oh, I didn't write all these down. Well, hopefully you have somewhat there. So let's put that 2 9/10. This starts the road. Then we go to 2 and what? 95/100. At this point, we're 3, aren't we? So here we go. And I could have put another 0 there. We're just going to put a 3 there because that's what I had originally. So as I said, let's slash as we go. We got that gone. We've got those gone. Now we are down to four values left. Everybody good? Everybody finished probably ahead of me. We now look at what's beyond, just beyond here. Now look here. We got 0, 3, got 3, 0, got 1, 0, and we got 3, 3. I think it's pretty obvious how we're going to put them in order, right? So let's go with our 3 3/100. There we go. Next comes in to be what? 3 1/10. And going back to our original numbers, say goodbye to those. And it's between our fractions, isn't it, to finish this thing out? Looks like 33/10. And then the last one we had was what? 10/3. There's your order. Everybody agree with me? Nod, say, oh yeah. And again, notice what happened. We were down to the last 2, and they're pretty obvious. They're very close, but it's pretty obvious which order they're going to come in. So there you have it. A nice way to just change them all to decimals, okay? Because remember, decimals are another way of representing that fraction the same way, all right? And these were all rational, so we were able to take them down to 2 decimal places and everybody's happy, right? We could have run that as far as we wanted, but we got it to 2. Perfect, all right? In order what we needed there, we had everything we have. So let's see if we got another one coming our way. This time, let's go a little step further. Let's put them on the number line and put them in order. Now, what I want to do is I'm going to borrow, let's see, I think we can pull this together here. I'm going to allow our endpoints of this, I said number line, but it's really going to be more like, let's make it a number segment. How's that? But we're going to go out to -1 here, and we're going out to +1. Now, right up in the middle, we're going to put 0. We're going to try to make this as realistic as we can, all right? And you know what? I just marked 1, 2, 3 places. I know I've got my least, I've got my middle, I got my greatest, all right, on the number line. So let's say goodbye to those, and let's worry about our others. And you know what? We may not need to rewrite many of these things. Do we know where -1/2 is? It's going to be right in between 0 and -1. So let's plop it right there. There is our -1/2. We have it placed on the number line. -3/8. Think a little bit about the location. It's a little bit, I was about to say a little bit less, but it's closer to 0 when we think about less than. So don't put it to the left of -1/2, but it's going to be a little bit here to the right, okay? And for those of you who'd like to go to decimal form, this is 5/10. This will be like, whoa, a -375 thousandths, so -0.375, which is going to give us this value right there. So let's do this. Let's put it just a little, oh, wait a minute, we got this 2/10 also. 2/10 is closer to 0 than the other, right? So let's see if we can find a little place for 2/10, -2/10, right there it goes. And then on down this way, 3/8 is going to be about right there. That's fairly close. That's fairly close to 1/8. So this is 3/8 right here we go. And it's very close to 1/4. So it might be a little bit to this way. Let's put our -2/10 right there. And we'll say this is -0.25. But you know what? We really didn't need to know that, did we? Because we were able to figure out. There's your benchmark fraction. So here we go. There's -1, -1/2. That's a -3/8, by the way, my friends. That's a -2/10, or 2/10 right there. That's an arrow. There's our 0. Thank goodness we only have one more number to place, right? We've gone through all of our negatives. Quite a few there, weren't there? That kind of got jammed up. By the way, this was right there, okay? Now, let's see. That's a decimal too, by the way. Some of you are just tuning in. Things get kind of smudgy, don't they, when you're trying to jam it all together. On the other side, I have 45 hundredths, which is almost halfway over. Not quite. So we'll put it about right there. And then 1, of course, is our greatest. The whole idea was trying to get them in order. We do have that. -1, -1/2, there's -3/8. -2/10, then comes 0, and finally go to your positive values. So that's how we can work those things, move them in order, play with them, and use a little bit of moments of, remember, I use benchmark type things. Where's a half? Where's a fourth? Oh, then 3/8 is somewhere between a fourth and a half, all right? Whether it's in the negative side or the positive side, it's somewhere in between those 2 points. So there you go, all right? So some quick math tricks, and let's see what we've got else hanging out for us here, all right? Let's see. Can we maybe do one more of these number line games, all right? And we'll see if we can move through a little quicker on this one. You all are saying, I got this one down, Ernie. I think we can do this. So give you a chance. Go ahead and draw that number line at home. And you know what? I think I gave us -1 and 0. I always do that kind of nice thing to help you get a boundary started. So there we go. There's -1. There is 1. Remember, negatives to the left, positives to the right. And 0 right smack dab in the middle. Once again, we're calling this a number line, but it's a part of the number line. So we could call it maybe a number line segment for those of you who like the geometry words. And we have placed a few things out. Now, let's go through and see if we can figure out where to put the other little guys. These are going to be very, very close quarter. In fact, they're nasty looking fractions. They aren't benchmark. Ooh, we always like those benchmark fractions, don't we? All right, so let's think, scratch that head a little bit, and let's think hard. Let's see where we're going to put 3/4. Where are we going to put 5/8? Those are both positives, right? Question is, who's larger, 5/8 or 3/4? And to save us a little time, let's go with it. Let's figure out. Let's see, 5/8, which is 5 divided by 8 on the calculator, gives us 6 25/100ths. So it's a little more than a half. Let's check out the other one, which we said 3/4. Everybody knows what 3/4 is. I believe it's going to be 75/100ths, right? You got that out there? So that one's always fairly easy to figure out. And that should tell us, put an enter on that, we got 75/100. So it looks like 3/4 is a little bit further to the right. However, it's still not quite halfway between, well, it is. Actually, it's more than halfway, isn't it? So let's go with about right there. That looks like a good place to put 75/100ths. And then how about the next one? Oh, about a little bit back this way. So there would be 5/8. There would be 3/4. And you know what, about somewhere right around in there, halfway, obviously, between 0 and 1, would be 1/2. So remember, these little guys are a little to the right. So we've got our positive values taken care of. You know what? -3/4 is going to play down here also. Right there it is, -3/4, fourth of the way between 0 and -1. So the question is, where do we find those other pesky fractions? So we're good with 6 out of 8, not bad. Let's go to the -1/6. Now, do I need to put a negative in front? If I need to, look where I'm pointing, my friends. There it is. That's the negative mark. We can do that. I personally think you should be able to just do 1 divided by 6 and say, oh, answer's negative, and life is good, all right? But nonetheless, we'll do it that way, and it looks like a crazy repeating decimal. We were afraid of that, weren't we? So let's check out and see what -2 divided by 13 is going to do for us. And we got to be careful. Not so much in time in there. They are right, almost, well, they're close. They're very, 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 very close. So who's closer to 0? Take a look at my two numbers here. I've got a -16, with all practical purposes, it goes like a 17/100ths, okay? Here, we're all practical purposes, about 15/100ths. This one, -2/13 is just a wee bit closer to 0. So, and it's not, oh, it's not even a quarter, is it? So let's kind of get a benchmark moment here. There is a quarter. So we are back this way, both of them. So how about it? Let's play it pretty close here. Which one did we decide was small? That was that -2/13. So we'll put it right there. And then almost, yeah, not quite on top of each other, but very close. And I'm going to put it up here, is going to be our -1/6, just a little further away. But here's the order. -1, there you go, first. -3/4, got it. Then comes -1/6, -2/13, jam close together. There comes your 0. And there comes 5/8, 3/4, and 1. Seems like the positive ones always come out a little better. And those are basically kind of benchmark type fractions. So there you go. Wow. A little bit of ordering values in number line city, but all those are rational. They're all rational, so they're good to us. So let's see what our next problem is going to ask us, okay? Let's see what we've got coming up here. Quick little word problem just to get us a little bit in the mood here. Keep in mind, it's rational day, right? So I'll give you a hint. This is going to come out nice and even. We're not going to come out with a nasty square root of some sort. We're going to come out with a good answer. Always good answers, right? Let's see what we've got here. It says, Jacob paid $4 a square foot for flooring to be used in a square room. All right. So I'm thinking I have a square room here. That means the length and the width are both the same. And he spent $1,600 on the flooring. How much is the side of room to the nearest foot? Wow. That was a big jump, wasn't it? Let's do something about this square foot and dollars of square foot, and then also how much flooring. Let's find out how much money. No, we got how much money, don't we? Let's find out how much square footage is in this room. That's what we need to figure out. The money numbers will lead us there. So let's see. We got 1,600, and we're going to divide, my friends, by 4. That was pretty straightforward, isn't it? That's going to give us $400. Now, let me go back just a second. Can we make that, you realize that could be written as a fraction? 1,600 over 4. That's rational, okay? Like I said, answer is going to be rational today. Well, let's hope it stays rational because we've still got to do one more thing. It's going to give us 400. And it's not dollars, is it? It's actually what? Square feet. All right, so we've got to make sure because we're dividing dollars by dollars. So that basically dollars go away. Those units are gone. So we've got 400 square feet going here. So definitely no dollars. Everybody good on me? That's not a 1 either. That's just a smudgy where we got a little carried away and put our dollars where we shouldn't have, all right? So 400 square feet, I'm in a square. I'm in a square room, all right? That means my length times my width gives me the area. So I've got what? I'm going to say side squared for a side because length and width are the same, right? Nod your head out there. You agree with me? Yeah. Equaling how much? 400, which is good because we can take a square root of 400. And our S would equal 20 feet. Those are our dimensions. Each side of the room would be 20. How about if I ask you the perimeter for that room? 4 times 20, exactly, be 80. But we're going to settle for the answer that I asked for, 20 feet, okay? Notice I didn't say square feet there. That's undone when you go back to your dimensions of the room. So a good quick problem there to play a little rationality. All right, let's take another look here. Question we have here, determine whether 5/8 becomes a terminating or repeating decimal. Check that you can return to the same fraction from the decimal. Oh my goodness, how about that? Well, let's see. We've got 5/8 and we're going to change it into a decimal. Now, what does terminating mean, my friends? What does it terminate? It means it ends, right? Like Arnold Schwarzenegger, the Terminator, he terminated things. That was his whole line. That's why he's called the Terminator. So we're going to have an ending to the decimal, or repeating means it does just that. It starts repeating itself and you never get to an end of it. So let's check and see what 5/8 is going to do. We'll do it the long way for our younger viewers, and then we'll also just go back and check you on the calculator. How about it? We got 5/8. I think we've done that already in the show, haven't we? But some of you may be looking at this segment separately, all right? So let's check and see what we're going to do. Divided by, that's what this means, rational. 5 divided by 8, all right? So let's do that. And by the way, to our younger viewers and to some of our adult viewers, that means the 5 is on the inside and the 8 is on the outside, all right? Remember I said 5 divided by 8. Or you could say divide 8 into 5. That's the way you can get those numbers, but it means the same thing. But this is what you've got to be able to translate it as. So put your decimal there. We're going to change it to a decimal. Put that 0 and let's start doing some division. Let's see, how about it? 8 into 50. Notice I had to put that 0 because I can't take 8 into 5, right? Everybody got that? So let's play it out. How about it? Put a 6. I like a 6. And I like a decimal right there too. So let's go right ahead and say 6 times 8, which gives me 48. Little mental math. Everybody can subtract 48 from 50, right? Think of your money. $50 minus 48, you only got 2 left. Bring out the 0. Another 0 coming out, because that basically means we're keeping 5 the same thing. We can have as many zeros as we want to. We still have a value of 5. Now, bring that 0 down, straight down. 8 goes in there, what, 2 times? 2 times 8 gives us, 16. Everybody got those times tables? Subtract. How about a 4? And bring one more 0 down. I told you, looks like it's going to terminate. Well, it did earlier, didn't it, when we put it in the calculator, so it should now. There comes the 5. 5 times 8 gives us 40. Nothing left over. And again, if we'd gone to the calculator, as we did earlier, when we took and we changed to compare the decimal values of 5/8 and 3/4, there we have it, all right? 625 thousandths. Now, the question says, check to see that we can get back. Are we going to check? We're going to check, right? Everybody's ready to check? Let's check. Put that 625 over 1,000. Woo! Wow, we know 5's going in there. Let's do it. 5 goes in there, and let's do some quick mental math. Go in there 125 times, I believe, and you got a 200. Already things look better. Oh, we can do 5 again. Dear friends, let's divide by 5 one more time. Let's have fun, all right? That gives us, by the way, 25. Think about it. $1.25, 5 by 5, 5 quarters, right? Oh, underneath there, you can do 5 into 20. Gives you 40. Oh my goodness, we got zeros and fives again. Let's do it one more time. 25 over 40, and let us divide a 5, and look what we got. 5 over 8. Checks back in. Is it terminating? Oh yes, it had an ending. Can you get back to 5/8? Yes, you can. Now, some of you probably got a question, what if it had been repeating? We have to wait for another show because we're about out of time. Hey, thank you for tuning in this afternoon. Summer school has been fun, I hope, for you. Hopefully a nice, easy piece of cake today, and also a little thought maybe on the area problem. But you know what? We're going to be back for some more fun of summer school. You never know what's going to happen here, and we will see you again next time.